Right now, we're going to be doing in situ science with static landers. To start us off, we have Noah Petro, who will be talking about digging into the freezer, exploring the floor of Amundsen crater.
Hi, I'm actually going to be the part of Noah at the moment. So this is exploring Amundsen crater. So the interesting thing about Amundsen crater is that it has a very interesting PSR region. Next slide, please. So PSRs, just a brief explanation of PSRs. These are permanently shadowed regions. So typically under 150 Kelvin. In that case, just looking at this figure, an example site here, you would have some amount of sunlight, but really driving into the colder temperatures. So this area would typically have about 60 days worth of illumination over an 18-year cycle. But having a continuous under 100 Kelvin region in Amundsen can really allow for different kinds of volatiles, not just water ice, which is very exciting. So between 60 to 70 Kelvin, it's really good for something called volatile organic compounds, or VOCs, to potentially be stable at the surface and certainly at the subsurface, including formaldehyde. So interactions of the water ice and different kinds of organic molecules would certainly be an interesting drive toward PSR exploration. Next slide, please. So some of our scientific objectives would obviously be, what is the nature of the volatiles present? What's the abundance besides just the function of temperature? What's the crystallinity? How do these volatiles behave between illuminated versus non-illuminated areas within Amundsen? Obviously, the measurement of the VOCs for astrobiological implications. How are these potentially the building blocks of an early solar system, and certainly an early lunar surface? And then the obvious one is ground truths for Viper, for Trailblazer, and other planned polar missions. So what's exciting is that there's a plethora here of example traverses for PSRs, telerobotic traverses, and certainly a number of community white papers to better understand polar volatiles. Next slide, please. So the obvious required capability is to work at extremely low temperatures, preferably under 100 Kelvin, and then also potentially in the dark. So you would need to have some sort of short traverse to go in between your light and dark regions quickly enough for communications, but then also traverse back into a dark, deep PSR. Another interesting instrument to be required for the VOCs would be mass specs for those organics, so something similar to the Mars Organic Molecule Analyzer. So such a mission would certainly have some sort of in situ measurements, but also potentially sample return. But the challenge with sample return would certainly be some sort of cold storage, and that could certainly be up for a discussion later. Next slide, please. Some enhancing capabilities would certainly be diving deeper into the traverse. So in that case, you would still have a much darker, non-illuminating areas, but trying to get into the colder temperatures. What kind of more organics can you have? The colder you are, the more hydrogen sulfides, ammonia type ices that you can have there as well. And then could there also be potential for rover and penetrator type sciences involved? So it's not just a seated lander, but also could you have an array of smaller instruments at these PSRs? So very exciting science for potentially at Amundsen crater. Thank you.
Okay, fantastic. Thank you.